Another important behavior known as azeotropes. After reaching mixture composition of 95.6, ethanol and water, which are 4.37, further purification by fractional distillation is not possible. We mean to say, if we started with a 50% solution, we can reach up to 95% of ethanol and 4.37% of water, but not further than this. And this ethanol-water mixture boils at 78.2 degrees Celsius. This constant composition, which can't be purified further with distillation, is called azeotropic mixture or azeotropic composition. So azeotropes are binary or multi-component mixtures having the same composition in liquid and vapor phase and boils at a constant temperature. Remember the two critical points. Azeotropes having the same composition in gaseous and in liquid phase, and they boils at a constant temperature. So because of that, further purification is not possible. There are two types of azeotropes called minimum boiling azeotrope and maximum boiling azeotrope. Minimum boiling azeotropes, the mixture boils at a temperature lower than any of the binary components. Let's take an example. This is a diagram for minimum boiling azeotrope. This is above this line. This is a vapor phase separating line. This is only vapors. Below this line, solid line, these are only liquids. And between these two, vapor and liquids do exist in equilibrium. So let's say we start with a composition at point A. This is a liquid with a X and Y composition. X is a certain percentage. X will be in minimal quantity, Y will be in higher quantity. You see here, we start heating it up. From here, we supply the heat. We reach to vapor here, vapor phase, it heats it up. We cool it here from B point. That's what we do. These are two phases. We heat it up from A to B. Then we condense it back from B to C. Then we get it, you see here concentration at B point, which is vapor phase, higher in terms of X than at point A. When we condense it, it comes at point C. So now our compound or solution we have distilled rich in X then at point A. We heat it again, we go to point D, which further increases the X concentration, and we again cool it back, reach point E, and by doing so, finally we reach the point this, which is converging point for vapor and liquids, and here only liquid phase do exist, and its constant composition for X and Y. Further purification at this point is not possible using distillation because we were using this liquid and vapor equilibrium to shift from one liquid to another. So this is how minimum boiling azeotropes we get. Here you see this is a pure boiling point. This is another pure boiling point, and our azeotropic point is lower than any of these two. Maximum boiling azeotropes. Maximum boiling azeotrope, the mixture boils at a temperature higher than any of the one component of azeotrope. You see here 190, but it boils at 115, the mixture azeotropic point, at composition 0.7 and 0.3. How it will happen in maximum boiling azeotrope? We are here, and this is liquid vapor equilibrium. From here, we reaches to this point directly. It's a liquid. We heat it up. Then we reach again to gaseous mixture point here, which is in equilibrium. Further here, you see it's in, because these points are in equilibrium, they are at the same temperature. These 2 points are in equilibrium. So from here we get liquid, that we can heat it further. Finally we can reach to this azeotropic point. But after reaching the azeotropic point, no further purification is possible. Colligative properties. They are also known as the democratic properties. So why we are calling them democratic properties? Because all properties that depend only on the number of solute particles, irrespective of their nature, relative to the total number of particles present in a solution, are called colligative properties. So it simply means irrespective of the nature of individual molecule or ion present, they contribute equally. Only thing that matters is the number, how many of them are present. It is just like a democracy. How many votes are there to win an election? So similarly, that's why we are calling them democratic properties as well. Relative lowering of vapor pressure of solvent. It is one of the colligative property we just saw. Depression of the freezing point of the solvent, another colligative property. Elevation of boiling point of solvents, colligative property, and osmotic pressure of solutions is also colligative property.